Hello, this is Mr. Mola for Lesson 4-1, Graphing Relationships. So this is going to be more of an English lesson than a math lesson. You really just need to pay attention to the words and what they're saying and either draw the appropriate graph or pick the graph multiple choice wise or say what could be happening in the graph that makes it go that way. Okay, so if I have something like this, here's some keywords that would help us. If I see a straight, going up kind of like that, some words that we could use are increase sharply or dramatically, quickly, rapidly. We see this small decline right here. We could say it decreased steadily, gradually, slowly. We see these kind of bumpy marks right here. So it rose variably at an uneven pace. We see a straight horizontal line or remain constant or stay the same. There's an increase slowly or gradually. And then there's a dramatic decrease right there, going all the way down. So decrease sharply, dramatically, quickly, rapidly. And then there's another one where it's kind of bumpy, but this time it's dropping, so dropped variably or at an uneven pace. So if I had something like this, I'm picking which graph says that. So each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no more leaves on the tree. Choose the graph that best represents this situation. So, and we look at our labels here. So this vertical gives us our leaves. The horizontal gives us our time. So we're starting off with leaves on a tree. Okay, so both of them aren't starting at 0, so that's good. They're starting pretty high in the graph. That doesn't eliminate anything. So each day they fall from the tree. Well, we can eliminate A because it doesn't say that the leaves are growing on the tree. It said the leaves are falling from the tree. Okay, so B is still in play and C is still in play. One day a gust of wind blows off many leaves. So that means we're going to have a strong decline, like in B, not a constant, the leaves stayed on the tree even though there's a big gust of wind. So we can eliminate C based on that second sentence, so we know it has to be B. B is the one that has the leaves falling from the tree, there's a big gust of wind, and then eventually there are no more leaves left on the tree. Okay, kind of the same thing here. The air temperature increased steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Which graph says that? Okay, and this one we can eliminate from the first sentence. So the air temperature increased steadily for several hours. Well, graph A, you see, it doesn't increase steadily. Graph B, it doesn't increase steadily. Graph C says right there, it increased steadily for several hours, and then it remained constant. At the end of the day, the temperature increased slightly before dropping sharply. So this one would be a graph C. That says exactly what the picture does. Let's get one where, so you're going to have two kinds of graphs. So you have a continuous graph, which is what we just saw, the ones that are, we're measuring it based, every second of every day. But there are some times where we have discrete graphs. So this would be ones where it's only points, no lines. This would be something if you, measured that tree every 2 weeks or measured that tree every day. Or, if your parents still measure how tall you are every birthday. So you're only measuring yourself one time. You would get a discrete graph. You wouldn't have that constant measurement. Suddenly before your 13th birthday, you don't grow 3 inches. You've been growing, slowly throughout the whole year. So it's not really fair to say that you grew 3 inches on your 13th birthday because you really didn't. So that's where we do something with a discrete graph. So you're going to have dots. So something like this. So the graph on the theme park is a discrete graph. It consists of distinct points because each year is distinct and people are counted in whole numbers only. So you're saying they took each year, measured how many people came to this theme park, and you could see from the graph that it's going down each year. So not good news for that theme park. Let's get one where we have to write the graph. So something like this. So write a possible solution for this graph. So we have speed and we have time. So it looks like we're going pretty fast to start, but then we slow down, and then we remain constant for a little bit, and then for some reason we're slowing down again until we end up stopping. So something we could say, a car approaching traffic slows down, drives at a constant speed, and then slows down until coming to a complete stop. So that makes sense. You see, you're kind of far away. You see the light turn red, so you're going fast. You're going to slow down. Maybe hope the light turns green again, so you're going to stay at a constant speed, realizing it's not going to turn green. You step on the brakes until your car is stopped at that red light. So that would be an example. Here's one of a discrete graph. So write a possible situation. So here we have pizzas bought versus students. Well, when the number of students reaches a certain point, the number of pizzas bought increases. So if you're going out with 5 friends, you're going to get, a certain amount of pizzas than if you only go out with 1 friend, or if you go out with 10 friends. So the number of pizzas are going to change depending on how many friends you're going out with. So this graph would kind of be something like that. You go out with 1 friend, maybe you're only ordering 1 pizza, but suddenly if you jump to, 3 friends, well, then you probably have to order a second pizza. So something like that. So you're either reading the graph, picking multiple choice from the graph, or writing a possible scenario for the graph.